Question 20 is asking about quite a lot of different areas of chemistry: atomic structure, redox, bond enthalpy, and electronegativity. So you have to identify the statement that is not correct. Statement B, the bond dissociation energy of hydrogen bonded to a halogen does decrease down the group because the halogen atom gets bigger, so the bond becomes weaker. So that's correct. C, the polarity of the HX bonds decreases down the group. That's also correct because the electronegativity of the halogen atom decreases as you go down the group because the atom is bigger and the electrons are more shielded, so the attraction of the nucleus for the pair of electrons in the covalent bond decreases. D, that statement's also correct. The halide ions are more easily oxidized. They lose an electron more easily because they're bigger and the outer electron is more shielded. The incorrect statement is A. And the reason for this is quite complex. Although the polarity of the bond decreases, which will reduce the strength of the permanent dipole-dipole interaction, the boiling point actually decreases because the effect on the permanent dipole-dipole intermolecular force is outweighed by the effect on the van der Waals intermolecular force. The van der Waals forces become bigger because as you go down the group, the hydrogen halides have more electrons, so you get stronger instantaneous dipole-induced dipole forces, and this outweighs the decrease in the strength of the permanent dipole-dipole intermolecular force. The correct answer is A. The boiling point increases because more energy has to be put in to overcome the stronger van der Waals forces between the molecules. The last question asks about the number of chiral carbons in the structure. A chiral carbon is a carbon that is attached to 4 different atoms or groups. This question is made more complex because of the number of rings. If a carbon is part of a ring structure, it will be chiral unless the 2 halves of the ring are completely symmetrical. I've labelled the chiral carbons in this structure and there are 6 of them. The correct answer is B. Carbons involved in double bonds cannot be chiral, so that you can't have a chiral carbon that's part of a carbon-carbon double bond or a carbon-oxygen double bond. And carbons that only have 2 bonds in a skeletal structure can also not be chiral because if there's only 2 bonds in the skeletal structure, it must be attached to 2 hydrogens, so there are not 4 different atoms or groups.